Hey, Mr. Yashki here with Algebra 2.1 Inequalities. So there's a major difference between an inequality, chapter 2 basically, and an equation. An equation means equal to, and then an inequality is not equal to. So an inequality is just something that's not equal to. There's 5 different inequalities, although we'll concentrate on what I would just say are the main 4. So one inequality is less than, and I would write it like this if I'm comparing the left side to the right side. And depending on the keywords, especially if you're given a phrase or a word problem, you want to look for keywords to determine the type of inequality that you're going to write. But some of the keywords for the inequality that I just wrote could be less than, could be fewer than, could be below as well. So an example, especially an algebraic example of an inequality, if I have a variable x is less than 2. That's how I could read it if I read it from left to right. If I read the right side first, 2 is greater than x. That's how I would read it. And then when we graph an inequality, if x is less than 2, that includes all the numbers up to, but not including 2. So all those numbers that are up to, but not including 2, would be the solution of that inequality. And then to show that on a graph, I would graph that, first of all, just on a number line. And then the way that we write number lines, we always put 0. 2 is on our number line as well, to show all of the solutions of that inequality on a graph. Okay, a number, for example, 0 is a solution to that inequality. There's not just one solution. 0 is not the only number that's less than 2. 1 is less than 2. 1.5 is less than 2. -3 is less than 2. Okay, there's an infinite number of solutions to that inequality. And then to represent that on the graph, we want all the numbers up to, but not including 2. So to show that 2 is not included, we make an open circle or a non-filled in circle. And then everything to the left of that shows all the numbers that are less than 2, that are under 2, that are fewer than 2, any way that you want to describe it. And so we fill it in to the left of 2. Again, the open circle or non-filled in circle at 2 means that the number is not included. So all of those numbers that are filled in there are solutions of the inequality, and that's shown by the graph. Okay, less than is one type of inequality. Another type of inequality is just the opposite of that, greater than. So some keywords, or that inequality represents greater than. And then instead of fewer than, you could say more than, or above. Keep in mind, those aren't the only keywords. Those are just like very common keywords that you could use for the inequalities. But to represent that as an example, x is greater than -5. So again, just like with the first example, there's an infinite number of solutions there. If I ask you to name a solution, 0 is greater than -5. 8 is greater than -5. -3 is greater than -5. 2.4 is greater than -5. Again, there's an infinite number of solutions there, but that's how I'd read that. X is greater than -5. And then to represent that on my graph, again, I always want to put 0 on my graph. -5 is to the left of 0, and count out the number of spaces. So I'm going by ones here, -5. And then similar to the last example, all the numbers that are just greater than -5 do not include -5. -5 is not greater than -5. So we don't want -5 included. I can make an open circle again at -5, and then everything to the right. The examples that I mentioned earlier that are solutions to the inequality, 0, I think I said 8, -3. So everything to the right of that, I would fill in on my graph, and that's basically the solution set on a graph for the inequality. So we have less than, we have greater than, there's less than or equal to, basically less than with just one equal to part underneath it. But other keywords that you could use for less than or equal to, no more than. Say there's a capacity, a total number of patrons that could be in a restaurant, like the restaurant could hold no more than 100 people. It's up to 100 people, including 100 people. So another key phrase I just mentioned is up to. Could also be at most for that inequality. And as an example, something I just mentioned, let's just say D, the number of diners in a restaurant, have to be no more than 100, so less than or equal to. So then when I make my graph, still making it just on a single number line, I have 0. I'm not going to make 100 spaces in here, so I can go by, I'm going to go by 50s to make it easier. Here's 50, here's 100. And then to show the solution set to the inequality, D is less than or equal to. Now the number 100 can be included, specifically because of the equal to sign. So I want a filled in circle. 100 is less than or equal to 100. And then all the numbers that are less than or equal to 100 are to the left. So here's kind of a quick little trick or tip that you can use to figure out how to graph the inequality. If the variable is on the left, which is it is in this case, then the inequality basically tells you which way to shade in or make your arrow. All the numbers that are less than or equal to, notice the inequality points to the left. So all the numbers to the left of 100, including 100, satisfy or are solutions to the inequality. Okay, that's for less than or equal to. And then the opposite of that is greater than or equal to. So the opposite of no more than, since greater than or equal to is the opposite of less than or equal to, no less than, or you could also say no fewer than. I'm just going to write no less than. Instead of up to or at most, you could also say at least. For example, in order to get a passing grade, let's just say G is your grade, you need at least a 60% in class. So G is greater than or equal to 60 would be the inequality. And then to represent that on a graph, make my number line 0. Notice on the last example, I went by 50s. Probably don't want to go by 50s here. I could go by something like 10s, but I'm going to go by 30s to make it easier. 30 and then 60. So if you need at least a 60, if you just want to squeak by, then you can get exactly a 60. So 60 is included. And then everything above that, or greater than or equal to that, would be to the right. Or you can use like the little tip that the variable is on the left, so the inequality points to the right. And that means I want to fill in everything to the right. Kind of a general little tip that you could use. If there's an equal to sign underneath the inequality on the graph, then you should have a filled in circle. No equal to sign, so less than or greater than, you want an open circle. I mentioned earlier that there's 5 inequalities. Last inequality that's least commonly used, I'm actually going to write it above all of these because I'm running out of room. Below is equal to sign with a slash, and that's not equal to. Okay. For example, P, the number of people in my class, is not equal to 3. And then to show that on a graph, since P is not equal to 3, 3 is actually not included. I'm going to go by 3s on my graph. So on an open circle, and then everything that's not equal to 3 actually are on both sides of 3 here, but not including 3. For example, 8 is not equal to 3. 0 is not equal to 3. Negative 4 is not equal to 3. 3.1 is not equal to 3. So those are the numbers that are not equal to 3, although not equal to is less commonly used than the other 4 inequalities. So those are the basics of inequalities. This is part 1. Part 2 will go over some specific examples of inequalities.